one more video, one more topic, and that's electronegativity before I drop the other two videos I want to show you. Now, first off, before I get rid of the green, I wanted to show you that it's the exact same trend for electronegativity. Tiny, tiny. The arrows are pointing the same way. Huge, huge. Okay. So everything we talked about in the ionization energy video does apply, but I am going to go over it again. So here, I wanted to talk about this two different ways. One, electronegativity is about taking electrons from another atom. And we need to talk about that in terms of gaining and losing electrons, which I'm starting to do right here. These guys are trying to lose electrons and are therefore going to be positive on that side, the metal side. And then on the other side, these are going to try to gain electrons and are therefore negatively charged. Well, if you think about it, right, electronegativity is by definition trying to gain electrons. So all these things at -4, -3, -2, -1, they're trying to gain electrons. These are going to have high electronegativity values. But these are +1, +2, plus something. They're trying to lose electrons. They're not trying to attack. They're going to have a low electronegativity. And that works. So again, we use the same argument we did in ionization energy, looking at the charges. Positives transitioning to negatives over here. Well, the other thing we can do as well is look at the size. Same argument as ionization energy again. If you're a really big atom, you can't reach out and grab it. So for example, I have some bananas over here. As you can tell, I am not close enough to these bananas to take them. This is a low electronegativity. I cannot reach the electrons. I could yell, I could scream at the bananas, come over here, blah, blah, blah. Nothing's going to happen. Because they're too far away from me, I can't reach them. But something like my phone, which is close to me, I could take this right away. Or these little napkins I have for the whiteboard. Or I have some of my track stuff here I can grab. That's all because it's close to me. If it's so far away you can't grab it, it doesn't matter. I could yell at the bananas as much as I want to come over here. I want to take you. I'm too far away to reach them. And that argument with size works up and down and left and right. Big atoms cannot take things. They're too far away from those electrons to reach out and take them. Protons are too far away from those electrons. Whereas here, if you're a really small atom, you can get your protons really close and take them. That's another way you can look at it. Again, this would have a very low electronegativity compared to this. And this is getting stronger and stronger because the size is getting smaller and smaller. So again, either way you can think about it. The other thing I wanted to add really quickly is the noble gases do not have an electronegativity because they already have the 8 valence electrons. They are 100% stable. They're good to go. For that reason, they won't have any. This is the only curveball of the trends. You've noticed this has been behind in the last few videos. It's because it's electronegativity. So don't let this fool you. If it's saying, hey, what has the highest, what has the lowest, these are automatically low. These are 0. They don't have any because they're already stable. Why would they take anything if they already have everything they need? So that's the video on electronegativity. I'm going to be doing 1 or 2 more on these, putting it all together. I'm going to start making that right now.